Okay, so everyone, welcome to another edition of Sir Eman's World. Theme song, please. Tudum tudum tum 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 la 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 Sir Eman's World. Dun 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 la 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 Sir Eman's World. Dun dun dun. You will learn basics because I teach you in Sir Eman's World. Okay, and today's lesson class is fluid mechanics. But before we do that, let's have a guess the drawing contest. Guess the drawing. Okay, so is everyone ready? So how does the guess the drawing work? So guess the drawing works that you guess what I draw over here in this space over here, and then the first one to direct message me in Edmodo per section would have or would gain a +1 on their quiz score. Okay, so is everyone ready? So remember, direct message me on munsci.edmodo.com. Okay, so guess the drawing. So I'm going to draw here. Okay, so it's not a perfect circle. I'm gonna erase some parts of it. Okay, so we have here. Okay, so that's the drawing. So what is this? So what's that? So guess what that is, and if you're able to guess this one correctly, you would get a +1 on your quiz score. Okay? So let's move on with our topic, and our topic is obviously about fluid mechanics. Or discussion on how fluids behave. Now when we talk about fluids, we mean gases and liquids. So these are the fluids that we're talking about. And to understand how these gases and liquids behave, you must be familiar with terms that are, well, obviously involved in fluid mechanics. One such term is pressure. Okay? So when we say pressure class, pressure by layman's term, or by its operational definition, it's defined as the force exerted per unit area. So that's our definition for force. It's the force exerted per unit area, and it's written in symbols as P is equal to F over A. So that's our definition for pressure. Where P over here stands for the pressure, F stands for the force, and A, well, stands for the area. F, or the force, is expressed in newtons. The area, its SI unit, is the square meter. And pressure, the SI unit for pressure is the Pascal, named after the chameleon in Tangled. Joke lang. It's named after Blaise Pascal and abbreviated as PA, which is equivalent to, well, the units for force over the unit for area, which is the Newton per square meter. Now the Newton, as we all know, is equivalent to the kilogram meter per second squared divided by the square meter, and you would see that the Pascal, PA, 1 Pascal, is also equivalent to kilogram per meter second squared. So that's what pressure is. Now take note, class, that pressure is very much different with that of force. Pressure is not the same as force. They are never ever the same. So to clear that out, let's have the following example. For example, a person is pushing you. A person is pushing you on the back with his hands. So this is your back over here. It's your back as in likod. He's pushing you with his hands with a force of 40 newtons. And likewise, we're going to compare it with this scenario. Let's compare it with the scenario where instead of pushing your back with a hand, the same person exert the same amount of force, but he would be pushing you instead of his hand. He's going to push you with a needle. Okay, so that's a needle. Okay, needle or a pin, whichever the case may be. It's the same. It's going to push you with a pin. Now, which will hurt? Which will hurt you? Okay, so the answer. Okay, by the way, I would like to stress out that the same force is exerted on your back, 40 newtons exerted by the palm, and then the same force, 40 newtons exerted on you by the pin, being pushed on your back by the same person. Now, which will hurt? Now, by experience, we would know that the one that would hurt would be, well, the push exerted on you by the person using a needle. Why? Even though the same force was exerted on you, different pressure was done or was exerted. For example, in this case, the pressure exerted over here would be much lower as compared to here. Why? As we have defined earlier, sabi natin, pressure is equivalent to the force per unit area. Now, the same amount of force was exerted on each. So I'm going to draw F at the same size. But the area in which the force was exerted was different. Over here, how would you compare this area? So you'd know that the pressure was exerted over this area, and over here, the force was exerted over this small area. So as we would have noticed, the pressure was exerted over different areas. We have here a big area over here, and a small area over here. So we have there big area, and over here you would have a small teensy-weensy area. So how would we compare the force on each? So the pressure on each, sorry. So over here, the pressure, since as you can see, pressure is inversely proportional to the area. The larger the area, the smaller the pressure. And the smaller the area, what can I say about the pressure? The pressure would be larger. So comparing the two, the pressure is higher when on the needle as compared to a pressure exerted by the palms of your friend's hand. Okay, so mas malaki ang pressure kapag maliit ang area, mababa kapag malaki ang area natin. Kaya yun ang reason kung bakit masakit kapag needle, at well, hindi syempre masakit kapag tinulak ka gamit-gamit yung kamay. It's because of the area, even though the same amount of force was exerted. The same principle is applied, well, for example, when you're walking on mud. If you're going to walk on mud, tingin nyo, saan kayo lulubog? Kapag you're walking on your normal shoes, yeah, so let me write it down. We're walking on mud. Okay? In which situations would your feet sink on the ground? A, when you are walking with your regular shoes. Or B, when you are walking with, well, wearing stiletto shoes. And guess what the answer would be? The answer would be is that, okay, so where, write on the question, where will your feet sink. Okay, so as you would know, the answer is this one, letter B. Okay, so why letter B? Because on letter B, the greater pressure is exerted on the mud by the stiletto shoes. As we all know, the structure of the stiletto shoes is that it would have, okay, let's draw a shoe over here. So let's have here our normal shoe. Say this shoe is a Chuck Taylor. Chucks. Chucks, 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 chucks. Okay. And then let's compare it with a stiletto. Okay, I don't know how to draw a stiletto. Forgive me, ladies. I really don't know how. Okay. For example, this is our stiletto over here. So let's suppose that the same person is wearing the shoe and then the stiletto. Okay, so the same weight is exerted downward, or we get the same downward force exerted. We have the same force. However, the area in which the force is applied for each shoe is different. Over here in the stiletto, the force was exerted over a smaller area as compared over here. So again, the pressure here, the pressure on the mud by the stiletto is greater than the pressure exerted using regular shoes. That's why you would sink on the ground, well, on the mud, when you're wearing stiletto shoes. So it's advisable, obviously, that you don't wear stilettos on the mud. Okay? So that's the difference between, well, pressure and force, and how do we define pressure. So I hope that you learned something from that, and so ta-ta.